For me, what drives me most is curiosity.
It's a privilege to be free to explore and follow our curiosity, and at the same time have the opportunity to have an impact on society.
We have challenges ahead of us. The climate change is certainly one of them. The treatment of waste and the recycling of natural resources is certainly very important, where we as mechanical engineering can also have a significant impact.
This opens up very great doors for not only for myself as a scientist, but also my students to actually see the direct applications. In the Institute of Mechanical Engineering, my specialty is robotics, and specifically soft robotics. My lab works on a very unconventional robots in their form as well as their activity and their task space. We want our robots to reconfigure and adapt to the environment as well as tasks, depending on whether it's known or not.
My field is nanoscience for energy technologies. We mostly study how we can convert light energy into other forms, in particular into charges, and we try to study this process at the interface between solids and liquids, either to drive chemical reaction, or more recently we've started to study this to see if we can recuperate energy from evaporation processes.
I'm in solid mechanics, and so solid mechanics, we worry about everything that's solid. I do theoretical work, so I do computational theoretical work trying to predict when materials will deform, when they'll break, and then trying to design, try to understand things at a very fine scale, a very small scale, to try to design new materials.
I'm an experimental fluid dynamicist who's interested in unsteady flows. So a big challenge is to really do motions and create an environment that is realistic of the variable conditions that are encountered in nature.
We are bridging between mechanical design and energy. We design turbocompressors for making fuel cells more efficient.
I work in the field of biomechanics. We are building tools that resemble biological systems to be compatible with those systems. The study of living systems actually touches every aspect of mechanical engineering, starting from the design and the structures and fluids and thermal sciences, and finally the control theory. And here at EPFL in the Mechanical Engineering Institute, we have experts in all these different domains that we call pillars. And I think this is very important to have such a team to tackle such complex and difficult problems.
Being in the Mechanical Institute, where we have a diverse field of expertise, allows us to really open up our way of looking at science.
We can think out of the box. We have the freedom to think, to look around, to take time, to think about new ideas.
You're living in a very fast-paced world.
I really enjoy teaching, and I really enjoy being around students who are really curious and passionate. They also are the ones who have the most daring and revolutionary ideas.
The kind of teaching I like most is where you have a one-on-one interaction with the students, where you can see them grow from the initial excitement about a question or using a measurement technique to actually learning something new.
It's such an international community. My students are coming all around the world, and as well as my colleagues, so I feel very fortunate.
We are lucky to have excellent facilities, but also excellent students. And so the combination of all these factors really puts us in the best condition to pursue really challenging ideas.
Since I've been here, you could really see everybody evolve and grow closer together and see more collaborations occur.
Research has been for a long time a very competitive environment, but I also think that more and more the younger generation value collaborations, and this is going to allow us to explore new domains which no single group would otherwise be able to tackle.